So students, in this lecture, we will talk about certain concepts which are called as operators. We have seen operators in our introductory lectures, but now in this we will see operators in details. We will talk about relational operators, logical operators, if-else statements. What are if-else statements? Then we will talk about for loops in R, while loops, repeat loops, Boolean logical operators, then building a function in R2+, scooping, creating functions, calling functions, and exercise scooping. So these are the contents that we will talk in this session and try to understand the basic constructs of R programming. Now, let's understand some situation that what is a relational operator and why it is needed. Consider a situation where I have to print the name of those students whose age is greater than 18 and who have received their driving license. So what will I do? I will be having a condition over here that if the age is greater than 18, I will display a message that you get a driving license. So the relational operators carry out such kind of comparisons between the corresponding elements of the operands. So what are the two operands here? One is the age of the person and the other one is the current age. So the age of the driving license is 18, greater than 18, and what is the age of the person? That is depending on from person to person. So relational operators return a Boolean true value if the first operand satisfies the relation compared to the second, which means that if age is greater than equal to 18, it means true. I can say if A is greater than B and the value of A is 5 and B is 0, again true. I can say if the salary is greater than 10,000, true. So that is how we compare the Boolean values. We compare two values and returns a Boolean value. A true value is always considered to be greater than the false. Why? Because true is represented by 1 and false is represented by 0. Let's talk about less than symbol and understand what is this operator. Now, this operator returns true if the corresponding elements of the first operand is less than that of the second operand. Otherwise, it will return false. So basically what we are saying is that if suppose there are two lists, if there are two lists, in the case we can see there is list 1 where we have the values true, 0.1 and apple, and then we have the list 2 where we have the values 0, 0.1 and bat. So here there are two lists with two different sets of values, and you can see over here that we are printing list 1 is less than list 2. So in this case, you can see over here that list 1 will be compared with list 2 element by element at that position. So true will be compared with 0 since true is greater than 0. So in that case, since true is greater than 0, we get a particular value output false because the condition is true is less than 0, which is not right. True is greater than 0. So that is why we got the output false. Likewise, 0.1 is less than 0.1, which is again false because 0.1 is equal to 0.1. Apple is less than bat. Now, apple is less than bat. Here also it is false. So that is how we are getting the output we get the output true. Why? Because apple is if we talk of it apple and bat, we will see that apple is less than bat. Alphabetically, apple is less than bat. So it is true. Alphabetically, we see B is greater than A. So that is how we are checking. And now have a look on the 6 very important relational operators which are greater than, equal to, which is denoted by equal to, not equal to, greater than or equal to, less than or equal to. So basically there are 6 operators, and for all the 6 operators there are descriptions. You can see here example, 5 is greater than 6 returns false. If I say 5 is less than 6, returns true because 5 is actually less than 6. 10 is equal to 10 returns true. 10 is not equal to 10 returns false. 5 is greater than equal to 6 returns false. And 6 is less than equal to 6 returns true. Now you must be wondering 6 is less than or equal to 6 returns true because this operator is checking either for less than or for equal to. So 6, if it is not less than, at least it is equal to 6, and that is the reason it has returned true. So these are the 6 operators that you have seen, and these 6 operators are used to compare the values. Let's have a look of the relational operators with the help of some example and data. So now we all know that less than equal to is denoted by the symbol less than equal to. It returns true if the corresponding element of the first operand is less than or equal to the second operand. Else it will return false. So now the command is like input list1 where we have given the data C true, 0.1, apple, and list2 where we pass C 0.1, bat. So these are the two lists. Now I want to print list less than equal to list2. So we can see list1 less than equal to list2, and the output is false, true, true. So you must be wondering why the first value is false. The first value is false because true is less than equal to 0, which is not correct. True is 1 and 0 is 0. So true is 1 means 1 less than equal to 0. We cannot call it a true. So it is false. And like that, 0.1 is less than equal to 0.1, which is true. And apple is less than equal to bat, which is again true because apple is less than bat. So that is how the less than operator is working. Likewise, we have the greater operator, which is returning true if the corresponding element of the first operand is greater than the second operand. Otherwise, it will return false. Here you can see that the input remains the same, which is list1 and list2, and you can see over here the output. The output is true, false, and false. So you can see over here that the code remains the same. In all the 6 relational operators, the codes remain the same. Only the relational operator is changing. And that is what we have to understand, that here we are just checking the relational operator. In the greater than operator, we have list1, which is true, 0.1, and apple. And again, we have list2. We are checking whether list1 is equal to list2 or not. If it is so, we are printing the output if it is greater than equal to, and otherwise we are printing false. And likewise, we have not equal to operator where again we have list1 and we have list2, and we are printing by checking whether list1 is not equal to list2. So if the two values of the particular two lists, the corresponding values are different, if they are not equal, which means they are different, only then you will get a true. So sometimes we have to check, are the two values in the list differing or not. So if they are different, in that case, it will be a true, otherwise it will be a false. So you can see over here, in this case, we are having a true for the first element and a true for the last element. But for the middle element, which is 0.1, it remains the same. Now, let's see how this program can be written in R and how we can see the output on the screen. So, our program to illustrate the use of relational operators, we can say vector 1 is equal to C and within brackets 0, 2. Whereas vector 2, we are having 2, 3. So, you can see over here there are two vectors, vector 1 and vector 2. Now, performing the operands, we can see over here, we have cat command we have used vector 1 less than vector 2. So, in that case, directly we are writing vector 1 less than vector 2 and new line. And like that, in the next cat command, we are writing vector 1 less than equal to vector 2 and so on. So we have incorporated 5 commands, and with the 5 commands, we are performing 5 operations: less than, equal to, greater than, equal to, and not equal to. and accordingly the values. Which values? The values of vector 1 and vector 2 are compared for truth or false. So you can see that 0 is less than 2. So vector 1 is less than 2 and I'm getting a true in the first line of output. Likewise, 2 is less than 3. Again, I'm getting a true. So likewise, element by element, the values are compared for all the 6 operations of relational operations, and then we are getting the result on the screen. So that is how we write the command. We can incorporate the vector comparison part within the cat command, and then and there the two vectors will be compared and their result will be displayed on the screen. So you can see, students, this is such a compact notation. With just two commands, I have created vectors, and within the cat, I am comparing the vectors and I'm displaying the output on the screen. What are logical operators? You must have heard about truth tables, that we have a truth table, and if there is an AND operator, in that case, if both the conditions are true, only then the output is true, and if both the conditions are false, then only the output is false. So such kind of things. Where can we find the logical operators? We can have logical operators where we have to have multiple conditions. So in that case, we see if the conditions are true, if both the conditions are true, we can very easily have a final output. But if any of the condition is false, in that case, what we will do? In that case, we have to check whether the output will be true or false. So you can see over here, logical operations simulate element-wise decision operations based on the specified operator between the operands, which are then evaluated to either a true or a false value. So any non-zero integer value is considered as a true value, be it complex or real number. Now let's have a look of the element-wise logical AND operator. This operator will return true if both the conditions are true. So we will get a true only if both the conditions are true. Let's have a closer look of the input, where list 1 is the first vector, which is true, 0.1, and list 2 is the second vector, which is 0, 4.3i. So these are the two values. Now I am applying the logical operator and I'm writing print list 1 and list 2. So you can see the output, that the output is false followed by true. Now you must be asking why the first output is false. The first output is false because the first two inputs are true and 0. So the first two inputs are different. They are not same. So we can say first is true and the second one is false because 0. So true and false. So the final output becomes false. Likewise, the second one is true because both are non-zero values. Both the integers are non-zero values. 0.1 is non-zero and 4.3i is also non-zero value. So both the values are true. So when both the values are true, only then the output gets true. So that is how we consider logical operators in R.